Hi, my name's Dan, and this video is one in a series of videos about using materials in Unreal. And in this one, I'm going to look at some light interaction stuff, particularly around the area of specularity and shininess in materials. So the setup I've got here is a standard third-person template. I've not added anything at all, but I am going to add a new material. So I'm just going to right-click there and choose material and call it mats. We're actually going to spend most of the time inside that material. So I've opened it up for edit. I'm just going to minimize it briefly as I'm going searching for a couple of textures that I'm going to use, which are in textures. Now these are part of the starter content, and I'm looking for, that's not what I want to have open. I'm looking for material gold. So it's T underscore metal. There we go. Metal gold, and there's a normal map there as well. So don't worry about texturing and about how textures work. I will do that in another video coming up. These are just to get some basic look to this material. I'm going to plug the standard texture into there and the normal map into there. And we're going to be looking at these 4 pins here. So let's have a quick look at how the material looks. It's kind of, well, it's yellow, it's got dents in it, and this is the dents and the little imperfections are what are being caused by the, or displayed from the texture sample and the normal map sample, just to give it a bit of texture. But what we're focusing on is the shininess of this. And if you can see up here at this point in the material, there's a lightening of the material. It goes a bit whiter there, and it's like it's reflecting a light. And as I move it about, that light moves about on it. And that's called a specular highlight. Okay. And some of what we're going to do will deal with a specular highlight, and some of it will deal with reflectiveness of the material. So I come from a background where I've done graphics rendering in proper code, as it were, and doing my own lighting calculations. And this, the way that it's done here in Unreal, is a little different to that if you've done that in the past. And so in some ways, I struggle to get my head around it, but I think I'm not the only one. Because it's very versatile, but versatile often means also confusing. Anyway, let's look at these 4 pins then. The first one I'm going to look at is the roughness. And there is a default value of 0.5 if you don't plug something in here. All of these values take a value between 0 and 1. 1 means fully on, and 0 means fully off. And if we drag from here and we want to put a number in, so we want to determine our own number, we want to use constant, and it's changed the constant to 0. And so a roughness of 0, it looks quite shiny and it's quite reflective. And this highlight is kind of stretched out here as well. And you can see a reflection of these buildings in the background. We're going to change that a little bit. So we can go between 0 and 1. I'm just going to change it up to 0.2. So as you increase this number, which is the roughness number, it becomes less shiny and it becomes more matte, as it were. It still does have, it's very hard to tell at 0.9, it still does have a specular highlight on there. It's just not very strong at all. Let's bring it down a bit. 0.6. So there you can see that specular highlight's come back. Okay. So one of the things that's going on in Unreal is that with these 3 values here, all of them can affect the specularity on that shiny spot. Let's alter the metallic value. So constant And so a metallic of 0 is very matte, and it looks like almost concrete-like. We've still got a specular highlight, but it's very diffuse. It's not very sharp and spot-like. And that's partly as a result of the roughness. Let's take the roughness all the way down to 0. It'll just cap it at 0. And that starts to make it reflective, and the specularity comes back. But if then we increase the metallicness up to full metallic 1, it looks very different. It's very reflective. And you can see that the reflective light is affected by these bumps here, these nicks and dints. We've got all sorts of specularity going on around here. So you can make a balance between the metallicness, which does affect the specularity. It also affects how reflective it is in terms of real life things that you can see in it. But then once again, if you start upping the roughness here, let's go up to 0.3, it starts to reduce that and make it more diffuse, as if it's kind of the metal's been bashed around and worn somewhat. And that's quite an effective look for some gold there at those values. And if you reduce the metallic, that's 0.3, it starts to look less like metal and more like other materials. Now, the way these textures have been applied with these dints, it will always mostly look like either metal or concrete. But as we bring up roughness and bring down the specularity, it starts to look more like concrete. Those dints make it look less like a plastic, maybe. The plastic tends to be very shiny, but not very metallic. So let's try and decrease the roughness to 0. The metallic is also 0. Does that look plastic? It might be. So the thirds, so we're going to bring that all the way down to 0. That could be. It's kind of slightly reflective. It's almost like a glass surface there. Third one is more directly affects the specularity itself. So from my lighting calculations background, this is the one that I would naturally want to play with, but the Unreal documentation says that 99% of the time you don't want to mess with the specular value and you can just leave it at 0.5. But as you can see, if we reduce that down to 0, so all three of these now are at 0, we actually get quite a very strongly matte finish. There's no specular highlight that I can see on there at all. So it's almost like it's got kind of paint on it, but not a shiny paint, a gloss paint, or coated in something, possibly even that's kind of chalky. And, let's just mess about with these values a bit. Let's turn the specularity up to 7. And we'll start to get the specular highlights and the reflections back again. Let's just get a little bit of roughness on there. 1. Still fairly shiny. And let's go halfway in our metallic and see what we get. There we are. So that's looking, again, it looks more glass-like than metal to me on there. So the thing about these three values is it's kind of hard to predict what you're going to get. And really, you either want to be messing about with them until you get the values that you want for the surface that you want, or what is probably a more common thing to do is to go away and find somebody else's material and have a look at the values. Now, I'm doing this live off the cuff. I haven't prepared what I'm just about to do, which is I'm going to go into the materials, and we've got a steel metal here, okay? So let's have a look at the values that we've got. And so they've upped the metallic to 1. Their specularity, not the specularity, their roughness is being brought off from texture samples and is being interpolated between some values. So actually their roughness changes across the surface. They haven't messed with the specular. So let's close that one down. Fine. And let's have a look at another one. How about this rusted metal here? So this has got a lot of bumps on it, and its specularity is now coming out from a texture sample here. The roughness is at 0.98, so it's really high roughness for this. And they've left the metallic at 0.5. So that's my tip, is to kind of look at the parameters of other materials to see what they're using for the sort of materials that you're going to want. I seem to have lost the material that I was editing, so let's go back to it. Because I wanted to show you the last one here, which is the anisotropy, or anisotropy, I don't know how you pronounce it, which is, I've done a little bit of playing with this. It's a little bit unusual, and it affects the nature of the specular highlights. And what it says when you mouse over, it says, determines the extent the specular highlight is stretched along the tangent. Anisotropy from whatever, however you pronounce it, from 0 to 1 results in a specular highlight that stretches from uniform to maximally stretched along the tangent direction. I'm not entirely sure what it means by stretched along the tangent direction, but if I up that to full, then there's an effect that we get here, is that you can see a ring of light across the top here and around there. And if I up this to full as well, then that should become even more pronounced. And as we move around, that ring moves and changes. And so actually the specular highlight, which was a dot, gets spread out in a ring-like way on there. And I think that this, with the right kind of settings, would be useful to give a kind of brushed steel effect. Got gold rather than steel, but let's try upping the metallic. 10 to 1. I've got the roughness is down, but maybe we want to just improve the roughness slightly there. 0.3, and we'll bring the specular back to a normal value of 0.5. And this gives a kind of burnished appearance, and you can see all these strange lines of specularity that are going on there. And I think that they're as a result, well, they obviously are as a result of this anisotropy, but it's the kind of effect that you might get if you had like a brushed metal. So that allows you to do that. So that's a quick look at these 4 values: the metallic, the specular, the roughness, and the anisotropy. And I gotta say it again, I think there's no substitute for getting in there and playing with it yourself. And if you're aiming for a particular kind of material, it's trial and error, unless you have a deeper understanding of these values than I do. So yeah, I'm going to come back with another video soon, but that's it from me for now.